last class we discussed about this problem. We stopped somewhere, right? We will continue that. So it says you have a pinion having a teeth of 23 and drives a gear which is having a teeth of 57. So the profile is an involute. So they are given what is the pressure angle which is 20 degree. Module is given which is 8 mm. And addendum they mentioned that it is equal to one module, right? They are asking you to calculate what is the path of contact, length of path of contact, and length of arc of contact, and also the contact ratio, right? So first what we have done is we have just written what are the unknown known datas. So pinion, which is a smaller k, we always call it as a small t. So small t is equal to 23. So capital T is around 57, and pressure angle is also given which is 20 degree, and your module is 8 mm. So since addendum is equal to one module, that is also 8 mm, right? Then based on the questions asked, we write the formula, right? So the length of path of contact, right? So we can split it into two: length of path of approach and length of path of races, right? Addition of these two will be your length of path of contact, right? So first let us identify what is the length of path of approach. So the formula for that is root of capital RA square plus small r, sorry, capital RA r square cos square phi minus r sin phi. In this, if you look after that, so you know all the data, so whatever which is phi is your pressure angle, which is known. So capital R we have to identify from the module. So we identified. So module is d by t. We know that formula. So since diameter is 2 times your radius, so based on that we identify capital R is around 228. So we use the same for formula for small to identify small r also. So small r is also same, which you are getting as 92 mm, right? So after identifying the small r and capital R, we will identify capital RA, then small RA. So if I consider the gear, so your addendum radius of addendum circle is nothing but pitch circle radius plus addendum. So the value of our addendum. So that is what we identified. So we know what is the addendum, which is 8. So which RA will be equal to R plus 8. So we identified. So this is the formula. Now what I'm going to do is I'm going to identify what is the, we are going to substitute this, right? So that is what we are going to do. So let me consider this formula. Okay, I will write it directly, right? So first thing is I have to identify what is the length of path of approach, right? So length of path of approach is equal to root of
Root of capital RA square plus R square
so
cos phi
cos square phi minus r sin phi, right? So which I can write it as, so let me consider LOP, LOPA, right? Length of path of approach. So this is equal to root of
236 square
capital RA square. So
236
236 square
plus 228
plus,
square 228
so
square
228 square into,
cos square phi, which is 0.9396
so,
the whole square.
so I will write it down. So cos 20 the whole square, right? So minus capital R, which is
228
228
into sin
into
20. Sin 20.
sin 20, right? So you will get it as an answer, right?
So
I will try it out. So
240.755.
so there is one method here. Let me try it out whether you are getting the right right answer or not. So just this is some formula that is coming. Okay, have to fix this is L. Okay, let me consider. I think this is not coming. Okay, what is the answer you are getting? Can you solve it?
240.755.
So 240.755. Very good. So everyone is getting the same answer? Yeah? Yeah, it's separating. Okay. That is not possible for me. I think, okay, so this is going to 240.
0.755.
0.755. What is the unit? Mm. Yeah. So LOPA we identify. So similarly, we will identify for length of path of recess. Right? Length of path of recess. Which is equal to root of small RA square.
100 square.
Small RA square plus R square cos square phi minus R sin phi. Right? So we will write this. So which is equal to root of 100 square plus small r. So what is your small r? 90?
92.
92. Yeah. So it is 92 square into cos square 20 minus, so 92 into sin 20. Right. So what you are getting? So
100.7.
So 100.7 mm. So overall, so your length of path of contact, right? So overall, your length of path of contact is
341.4743.
It's equal to, it is addition of these two, right?
Yes, sir.
A plus LOPR. So
341.4743.
341.74.
4743, sir. 4743. Yes.
Okay, 474 mm. So I think it is addition of 240.7 plus 100.7, right? So something like this. 7. Okay. Just adding this, you will get what is the length of path of contact, right? So this is the two. This is one thing which we have completed, which is this one. Next, we have to identify arc of contact, right? So what you have to do, it is LOP divided by your cos phi, right? So length of arc of contact. I'll write it here. So length of arc of contact. It is nothing but LOP. So length of path of contact, LOPC, divided by cos phi. Right? So which is equal to, so 341.474 divided by cos 20. So what are you getting?
363.425.
So 363.425 mm. Right? So this is LAC. L, right? Length of arc of contact. Okay, let it be considered. So can you guess why the arc is higher when compared to your length? Can you guess it out?
Because we are dividing by cos 20, sir. Always cos is maximum 1. Cos or sin, their range is within 1. So if it is 1, it will be equal. If it is some other value, we will get fraction as a value. So when we divide by fraction, we will getting higher value.
Okay. Right. Actually, what is happening here is you have an arc, right? This arc, you approximating it as a line. Okay, this line is what we call it as length of path of contact. This is path of contact. But actually, when there is a mesh and when you look after the point traced on that particular contact, actually it's an arc, right? So you are approximating to a line, right? So since the line is lesser when compared to this arc, that's why. So arc is having higher value, right? So of course, that is why we are getting the cos 20 degree, which is greater. So arc is greater when compared to this arc, right? So higher value. So when you solve the problem, make sure that you get an higher value. So if there is any smaller, of course, you will get the higher value only. So if it is not so, that means you have made some mistakes. So mainly you check it out. Usually this happens when your calculator is in radian mode or in some other mode, gradient. So make sure your calculator is in degree, right? So this problem will arise only if your calculator mode is different. Okay, so make sure so when you solve that problem, particular problem, right? So the next one is, so we identify this also. The last one is contact ratio. So you have to identify what is the contact ratio for this particular problem. So let us identify what is contact ratio, right? So contact ratio is how much teeth you are having contact, right? When there is a mesh. So in these two gears, right? It is nothing but your length of path of, sorry, arc of contact divided by your circular pitch, right? It is length of arc of contact divided by your circular pitch. So circular pitch indicates the how much it is the distance between two consecutive teeth, right? So that is why we are dividing with respect to that to identify what is your sorry, what is the contact ratio, right? So can you identify what will be the circular pitch formula? Can you guess? Yes?
Pi d by t.
Pi d by t? Circular pitch. Is it pi d by t? Are you sure?
Yes, sir. Adana, sir. Pi d by t. Pg is equal to pi d by t.
Yeah, very good, very good. Right. So it is pi d by
T.
t,
Capital T.
right? Okay. So let us identify what is circular pitch then. Circular pitch is pi d by t. Sometimes they will also call it as pi m. Okay.
Okay, so module.
So m is the module, d by t is your module, right? So which is equal to pi into 8. So because you no need to substitute it directly, you can have module, you can substitute. So what is 8 into pi? So 8 into pi. You are getting 25.12.
132.
132, right? It is 25.132 mm, right? So now what you can do, we can divide it, right? You can divide with respect to the length of arc of contact. So contact ratio is equal to length of arc of contact is 363.425. So it is 363.425 divided by your circular pitch, which is 25.
The contact ratio is 14.461.
Sorry, 14.461. So 14.461. So which means approximately 14 teeth is having in contact. Are you getting it? Yes.
சார் ஒரு சமயத்துல 14 டீத் கான்டாக்ட் இருக்கா?
ஆமா ஆமா, ஒரு சமயத்துல வந்து 14 டீத் வந்து கான்டாக்ட்ல இருக்கு. ரொட்டேட் ஆகும்போது 14 டீத் கான்டாக்ட்ல ரொட்டேட் ஆகுது.
அப்ப அந்த அளவுக்கு பெரிய கியர் அப்படி இருக்கும்.
ஆமா ஆமா. So you can see what is the radius இல்லையா? So இதுல வந்து பாத்தீங்கன்னா
சார்
யா
சார் 14 teeth in contact னா அது ஆக்சுவலா both driving and driven gear வருமா இல்லனா வெறும் ஒரு
இல்ல
gear மட்டும்
both ஃபார் எக்ஸாம்பிள் இது உங்களோட கியரோட இது பெரிய கியரு, இன்னொன்னு இந்த சின்ன கியர் இப்படி இருக்கு ரைட்டா. சோ இந்த இடத்துல இந்த கான்டாக்ட்ல எத்தனை டீத் இருக்குன்னா 14 டீத் இருக்கு. Are you getting it?
ஓகே சார்.
ஓகே சார்.
Yeah. So that is how rotationல அந்த மாதிரி கான்டாக்ட் இருக்கு. That is what it indicates. Right? Okay. Any doubt in this?
சார் இதனால எது சார் இது கம்மியா இருக்கணுமா அதிகமா இருக்கணுமா?
எது?
இத வச்சு கியர் வந்து எஃபிஷியன்சி அதெல்லாம் ப்ரெடிக்ட் பண்ணுவாங்க.
No, actually பாத்தீங்கன்னா it is both ways. There is some positivity and there is some negativity, right? So we can't justify that. The problem is, so when you have higher number of teeth which is in contact, your velocity, your rotational velocity and your friction will be more, and easily you can able to transmit power, right? But at the same time you have a sliding velocity, right? So which is disturbing, right? நிறைய கான்டாக்ட் இருக்கிறதுல என்ன ஆகும்னா ரப்பிங் வெலாசிட்டி அதிகமா இருக்கும், ரைட்? ஸோ அப்போ இதெல்லாம் பார்த்தீங்கன்னா ஈவன் தோ தேர் இஸ் அ லார்ஜ் நம்பர் ஆஃப் டிரான்ஸ்மிட் ஆஃப் பவர், ஸோ கியர் வந்து சீக்கிரமா தேஞ்சு போயிடும். கேன் ஏபிள் டு கெட் இட்?
எஸ் சார்.
Yeah. So it may transmit efficiency will be more. So when the teeth is higher, but efficiency is more. But the life cycle of the gear is less when compared to that. Okay, so that's why. So there is both type. So either it may be whatever it is. It depends on the application what we choose. Right?
Okay, sir. Got
okay, we will solve one more problem related to this. Yeah, can you able to see that? This problem? Extra, there are a few more steps, things we have to identify. Yeah. So there are two mating gears with a module of 6.5 mm, which one is 19 teeth, one is having 19 teeth, other is having 47 teeth. So at 20-degree pressure angle. And addendum is given, which is 6.5 mm. So directly they are given. Sometimes they will say addendum in terms of module. So here they mentioned it directly. They're asking determine the number of pairs of teeth in contact, angle turned through by the larger wheel for one pair of teeth in contact. So இது என்னன்னா பார்த்தீங்கன்னா what will be the turn, what is the angle of twist which will happen when there is one contact. The contact ஒரு டீத் கான்டாக்ட் ஆயிட்டு வெளியில வர வரைக்கும் எவ்வளவு டேர்ன் ஆகுது, இது லார்ஜர் வீலுக்கு எவ்வளவு டேர்ன் ஆகுது. திஸ் வாட் தி क्वेश्चन இஸ், ரைட்? அண்ட் தேர் ஆஸ்கிங் யூ டு ஐடென்டிஃபை வாட் இஸ் தி ஸ்லைடிங் வெலாசிட்டி with respect to three category. So at the time of approach, at the time of races, and at the time, so at this pitch point, right? So they are given what is the pitch line velocity also for this particular problem. So do you have any doubt in the problem? Anything which you can't understand in this particular problem? Yes or no?
No, sir.
Sir,
Okay, we'll proceed. Yeah.
if they ask them the number of pairs of teeth in contact, then we have to find the length of contact, arc of contact, and then only we can find, no, sir. But it is 8 mark.
Yes. It's a 16 mark problem. So even though the statement is very simple, they say that you have only to identify what is the pair of teeth, right? So, but To identify the pair of teeth, you have to identify arc of contact, which means you have to solve everything, right? So that is what. Okay, let it be. So let us identify what are the given data. Then we will proceed one by one. So what are the given data? So first, they are given model M, which is equal to 6.5 mm. Next, small t is given. So small t is 19 and capital T is also given, which is 47. Right? Then they mentioned what is the pressure angle phi, which is equal to 20 degree. And addendum. They mentioned what is addendum. Right? Addendum is 6.5. Right? So these are all the datas. And of course, at the end, they are also given what is the pitch line velocity. Right? So pitch line velocity, which is equal to 1.2 meter per second. Right? Make sure everything is in mm. This is a meter per second. So while you are solving it, you have to convert this. Okay. Right. Now we will write down. So what are the things to identify and what are the formulas related to that? Right. So you need to identify number of pairs of teeth. Right. So number of pairs of teeth, which means
Contact.
you have to identify length of path of contact. Right? So we know if you want to identify length of path of contact, your formula, what are the data required? So you need what is RA, what is R, what is phi, what is small r, what is small ra. These are the data which is required for the formula. Right? I am directly writing out. So instead of writing the formula. Right? So these data, so you have to identify these data one by one. Right? So since you know the module, you can identify these things. Right? So you know what is the module here. So M is nothing but d by t or capital. Are you there?
Yes, sir.
Okay, okay. Sorry. So capital D by T. Right? So I will relate it one by one. So it is 6.5, right? So capital D, I don't know. T is 47 is equal to 6.5. This is one side. So other one is small d divided by T. T is 19. This also is equal to 6.5. Right? So what is a capital D?
Sir, capital D is 305.5 mm and small d is 123.
All for D. Oh, very good. So I'm getting the answer here. So just trying new technique here. Okay, so capital D is 305.5, but I need capital R. I don't want D. So which means I have to divide by 2.
152.75.
Divide by 2 R.
Yes, sir.
Yeah, 2 R is this. So 160.
152. 152, sir. 52.
Okay, okay. 152.75. So we're getting 152.75 mm. Right? So similarly, so we can also identify for this small d, right? I think we'll be getting 123.5, right? So I'm getting 123.5. So small d is
small r is 61.75.
Yeah, small r is 61.75 mm. Right? So now I will identify what is RA. So RA is R plus 6.5. Right? So which is equal to, just add this to find out what is RA. Right,
The
152.75.
capital RA is 159.25.
So it is 159.25 mm. What is small RA?
68.25.
6.5. So small RA is 60.
8.25.
68.25. Yeah. So now I got everything. So let us identify one by one. So first step, I need length of path of approach, which is equal to root of, it will be in capital letter, right? So capital RA square plus R square cos square phi minus R sin phi, right? Which is equal to root of 159.25 square plus 152.75 square into cos square 20 degree minus 152.75 into sin 20. Right? What is your length of path of approach? So similarly, you find it for length of path of races. Yeah, try it out.
So length of path of approach is 162.1415.
Sorry.
Length of path of approach is 162.1415.
Are you getting that much value? Can you check
Yes,
it out? So just a minute.
162 only, sir.
No. I think I made a mistake in the formula. That's why I'm checking it out. Just a minute. Sorry. I think there's a problem in the formula. So what is my formula? Let me check it out. I just typed here. Yeah, sorry. I think last thing also I made a mistake. It is minus here. It is not positive. Sorry. Yeah. Actually, the formula has to be minus. It is not plus. Right? So I think I have to change my previous problem also. I am just thinking out why, how much it is increasing. That's why. Okay. Sorry. So I will repeat that old problem. I think it has to be minus. Okay. The problem முடிச்சிட்டு வராத. Right? So I don't want to confuse. Right. So first we will complete this. Then we will proceed with that. So this has to be minus. This is not plus. I made a mistake. So please consider this is a negative sign. So both are negative, right? Yeah. So can you tell me now length of path of approach?
One 167.30. 16.730.
So sorry, 16.730. Yeah. So usually you will get a very
16.762, sir.
16.762.
762. Almost
Okay.
same as earlier, sir. Just I approximated, sir. That's all, sir.
Okay, 16.76 mm. Okay, so make sure it is negative. Okay, so next, length of path of viscous. That is also negative, right? So it will be minus. So it is root of RA square minus R square cos square phi minus, sorry, R sine phi. Right? So substituting the values. So which is equal to root of R square. So small r is, I think, 61 and 68. So this is 68.25 square minus 61.75 square into cos square 20 degree minus 61.75 into sine 20. So identify what is the value for this.
$14.811, sir.
14.811. Okay, very good. So it is 14.811 mm. So it is LOPR, right? So next we'll identify what is length of path of contact, right? So length of path of contact is equal to addition of these two, which is 16.76 plus 14.811. So what is the overall value?
31.58.
So 31.58 mm. Right? Okay. Next, we'll identify what is the length of arc of contact. Right? So it is path of contact, which is 31.58 divided by cos 20.
33.6103.
So it is 33.610 mm. Right? Okay. So now we identified what is the arc of contact. Right? So that is over. But we have to identify what is the number of pass in teeth. Right? So which is contact ratio. Right? Let us identify what is contact ratio. Right? Contact ratio is this length of arc of contact divided by circular pitch, which is pi m. Right? So this is equal to 333.610 divided by circle pitch, pi into m. M is 6.5. Right? What is your contact ratio?
1.6467.
So 1.646 approximately. 2 gears, right? 2 teeth is in contact. Okay, so when it is greater than 6.5, you can write as 2. So when it is lesser than that, you can write as 1, whatever it is. Okay, so any doubt in this contact ratio?
No.
Yeah. Can we proceed?
Yes, sir.
Yeah, what is the next thing you have to identify? What is the next thing you have to identify? Right? The next step is you have to identify what is the angle turned. Right? What is the angle turned by the gear? So angle turned. So that is what they are asking. Angle turned by the larger gear. Right? So for one teeth. Right? So to identify this, of course, you need what is the length of arc of contact, right? With respect to that only we can identify, right? So it is length of arc of contact you have to identify, then divide by what? Instead of circular pitch, you have to divide by the circumference of the gear, whatever which is having contact. Okay, so that is where you can able to identify the angle turned. Right. So, okay, let me write it out. So, angle turned by larger wheel, larger gear. Right. So, this is equal to, so length of path of contact. So, sorry, length of arc of contact divided by, right. So, length of arc of contact divided by your circumference of the larger wheel. Circumference of the larger wheel of larger gear into 360 degree. So because you have to identify the angle turned, right? So which means which is equal to length of arc of contact is 33.61 divided by the circular pitch. Sorry, by the circumference. What is the circumference? 2 pi r, right? So 2 into pi into, so we are concentrating on capital gear. So capital R, right, into 360. Because the larger gear is capital R, right? So which I can write as 33.61 divided by 2 pi. What is capital R? So it is 152.75 into 360. Yeah. So what is the value you are getting? Answer with about.
Sir, 12.6 degrees, sir.
Sorry, 12.6.
6 into 360, if you do means you are getting 12.6 degrees.
Okay, 12.6 degrees. So this is what the angle turned, right, by the larger wheel. If they ask smaller wheel, what you have to do?
Small
The
R.
same thing.
Circumference of
larger
one
diameter
thing
is
is,
smaller diameter.
yeah, instead of this capital R, you have to put a smaller. That's it. Okay. So this is the angle turned, right? So the next part is over. So this part is also over. So this too is over. Next, they are asking what is the sliding velocity at the time of engagement, what is at the time of races and at the pitch point. Sliding velocity at pitch point is 0. Right? Whenever you consider the pitch point, and the point la vandu pathina nadula irukku, so it is 0, right? So but you have sliding velocity at the time of engagement and disengagement, at the time of approach and races, right? Okay. So for identifying these two, what are the data required? Can you guess what will be the data?
Angular velocity.
You need?
Angular velocity.
What do you need?
angular velocity.
Angular velocity. Very good.
Distance from
Okay,
pitch
angular
circle.
velocity. Very good. Then?
Radius.
Yeah. So to
Pitch
identify
circle.
that angular velocity, we need radius. Then? So
இல்ல சார்,
you
அந்த
need
pitch circle கான்டாக்ட்ல இருந்து ரேடியஸ் அந்த சென்டர் வரைக்கும் இது டிஸ்டன்ஸ் ஃப்ரம் pitch circle to contact.
Distance from pitch circle to
Contact.
contact. That is what we call as a path of recess and path of approach. In the value, வேற ஒண்ணும் இல்ல. Correct?
Okay, sir.
Right, you have to use that. That's it. Okay, we will proceed with this. So let me identify pitch time velocity is 1.2 meter per second. So let me start with that. Right. So we are going to identify what is the sliding velocity. Right. Let us identify what is the sliding velocity. For that, yeah. Yeah, I muted. Okay. So can you able to get it? Yeah. So can you able to hear me?
Yes, sir.
Yeah. The sliding velocity is first you have to identify what is the linear velocity. Linear velocity is given, which is 1.2 meter per second. Right? So, but we know that this linear velocity V is nothing but omega into R. Right? It's a common formula. So when you write it in terms of gear and pinion, it will change. Right? So let me consider omega 1 as pinion and omega 2 as gear. Right? In that case, so V is equal to omega 1 R. And similarly, V is equal to omega 2 and into capital R. So where the R is always indicating the pitch circle radius. So we have to identify based on that. So now velocity. Velocity is, you know that it is 1200 because I am converting to mm, right? Because the small r or capital R, it is in mm. So 1200 is equal to omega 1 into smaller. What is your smaller?
61.75.
So it is 61.75. So this is 61.75. So from this, you can identify what is omega 1. Right? Just divide this, find out what is omega 1. So 1200 divided by 61.75. You're getting around 19.43
433.
radians per second. Similarly, we proceed with this. Right? What is omega 2? So this is 1200 is equal to omega 2 into radius of gear, larger gear. Larger gear, I think it is around 152.75. Right? It is 152.75. So what will be your omega 2?
7.855.
So 7.855 radians per second. Right? Okay. So let us look after the question. So we identify what is the sliding velocity. So sliding velocity occurs when the two gears are engaging. So which means you are the addition of these two, right? So okay, now let us go for what is sliding velocity at the time of engagement. Right? So sliding velocity sliding velocity at engagement. Right? So this is equal to omega 1 plus omega 2 into your length of path of approach. Right? So this is equal to omega 1 is 19.43 plus omega 2 is 7.855 into length of path of approach. So your length of path of approach is 16.75. So just multiply with 16.75. So what will get?
So this is the actual formula for sliding velocity, no, sir?
Yeah.
457.023.
So 457.02 mm per second. Right? If we want it in meter, it is 0.457 meter per second. Okay. So because we substitute the approach in mm, so we'll get like this. Next, sliding velocity at disengagement. At the time of disengagement. So the formula is same, which is omega 1 plus omega 2 into, instead of length of path of contact, you will have length of path of recess. Right? So this is equal to, so same, 19.43 plus 7.855 into
14.
your length of
14.811.
811. So we'll get what is the value?
404.42 mm per second.
4.2 mm.
42.
Okay, 42 mm per second, or approximately, so 0.404 meter per second. Okay. Any doubt
சார் அட்
in
பிட்ச்ல
finding
வந்து
this?
கான்டாக்டுக்கும் பிட்ச் சர்க்கிள்க்கும் 0 டிஸ்டன்ஸ், அதனால 0.
Ama, there is no distance, so it is 0. Yeah.
Sir, can I repeat, sir?
Right.
Why sliding velocity at which point is 0? One more time, can I repeat, sir?
Yeah, if you consider at the time of, let me consider here, you have this, okay, I will put a circle here.
அந்த கான்டாக்ட்ல ரெஸ்ட்ல இருக்கிறதுனால அது ஸ்லைடிங் ஜீரோ சார்.
ஆமா, இப்ப ரெண்டு கியர் இப்படி இருக்குன்னு வச்சுக்கோங்க. Right, so let me consider this is my gear. It is having contact, right? So pitch point என்றது என்னன்னா center to center distance of these two and mating location. So இதுல பாத்தீங்கன்னா இந்த இடத்துல இதான் சென்டர் பாயிண்ட் வச்சுக்கோங்க. இங்க இருந்து இது வரைக்கும் உள்ள சென்டர் பாயிண்ட்ல ஜாயின் பண்ணனா இந்த சர்க்கிள் இருக்குல்ல, பிட்ச் சர்க்கிள், அதுவும் இந்த சென்டர் டு சென்டர் டிஸ்டன்ஸ் கனெக்ட் பண்ற இடம் தான் திஸ் இஸ் தி பிட்ச் பாயிண்ட். ரைட்? இந்த கியர் வந்து கான்டாக்ட்ல வந்து எப்படி இருக்குன்னா இப்படி வரும். இல்ல சம்திங் லைக் திஸ். லென்த் ஆஃப் பாத் ஆஃப் கான்டாக்ட் இருந்து ரீசஸும் இப்படி வரும். ரைட்? சோ இந்த பாயிண்ட்ல வந்து பாத்தீங்கன்னா அது பாத்தீங்கன்னா இட் இஸ் செட்டட். சோ தேர் இஸ் நோ டிஸ்டன்ஸ். பிட்ச் பாயிண்ட்ல டிஸ்டன்ஸ் இல்ல, வெலாசிட்டியே இல்ல. ரைட்டா? அந்த பாயிண்ட்ல வந்து வெலாசிட்டி. சோ என்னன்னா, சோ இட் இஸ் லைக் ஒன் சைட் இட் இஸ் ஃபோர்சிங் தி ஃபோர்ஸ் வந்து இந்த டைரக்ஷன்ல அப்ளை ஆகும். ஒரு பாயிண்ட்க்கு அப்புறம் ஃபோர்ஸ் வந்து ஆப்போசிட் டைரக்ஷன்ல ஆக்ட் ஆகும். ரைட்? ஒரு பாயிண்ட்ல 0 இருக்கும் இல்லையா? தட் பாயிண்ட் இஸ் பிட்ச் பாயிண்ட். Can you getting it?
Yes, sir.
Yeah. So இப்போ வந்து கியர் டீத்ல வந்து தள்ளிட்டு இருக்கும்போது அது ஒரு பாயிண்ட்ல வந்து 0 ஆயிட்டு அப்புறம் திருப்பி நெகட்டிவ்ல போகும். ரைட்? சோ அந்த பாயிண்ட் தான் வந்து பிட்ச் பாயிண்ட். So அதுல தான் அந்த இடத்துல வந்து you don't have that velocity.
Sir, 1 minute, sir. Sir,
Yeah.
the sliding velocity pitch point is 0 because there is no distance or there is no velocity is 0 at that point.
See, actually there is a motion, velocity is there, but there is no distance. Distance is 0.
Okay, sir.
Right? There is nothing, you have something see, if this is the gear,
Yes, sir. Understood,
right?
sir.
Yeah. Okay.
Zero because
Okay.
there is neither length of path of approach or neither length of path of resist.
Yeah, yeah.
So it will
It is
have
in
an
between.
point, will have angular velocity, but it will not have any neither length of path of approach, neither nor length of path of resist. So it is zero.
Yes. Yes. It is neither pushing or pulling. That's it. Right? Okay. So I think I made a mistake in your previous problem. So I think this one I have to subtract it. Right? So this one should be a negative one. Okay. Try to change all these things. So இதே இது நான் வந்து அசைன்மெண்ட்டாக கொடுக்குறேன். இதே ப்ராப்ளம் தான் கொடுக்க போறேன். ஸோ ஆன்சர் மட்டும் நீங்க கரெக்டா நோட் ஆப்ஷன் சூஸ் பண்ணிடுங்க. தட்ஸ் எனஃப். Right? So I will give that as a problem. Right? Yeah, we will stop here. So next class we will discuss about interference. So what is the main purpose of interference and how to avoid that interference. So there is another set of formulas we'll be using it. So we will use that formula.